This summer I made this bike camper that's really cool, but also really sucks to pull with your own muscle. So in this video I'm going to be converting my bike to an e-bike and then building my own really big battery with hopefully like 100 kilometers of range, and adding some solar power and some other important fixes to the first version, so stick around. So first I'm going to take off the frame and weld on some bars around the wheels so that the axles are supported on both sides, like I was talking about at the end of the first video. So first I have to sand off the paint, and then I'm getting a rough measurement on the wheels, which are 26-inch rims. So I made the longer bar 32 inches, and then for the width I just measured the width of the hub and spacers and then added on about a ½ inch because I can easily grind this down to the perfect width later. Then I'm using that same 1/4 inch by 3 inch flat bar to make another support for the other side of the axle. This time I just cut the width to 3 inches. And then I grinded the edges a little bit smoother. And then for the hole for the axle, I marked the center point on the width and then 1 inch up from the bottom so that it matched the support on the other side. Then I drilled it out with a pilot hole and then with a bit the same size as my axle. And once my somewhat passable welds were done, I used a cutoff wheel to slot out from the bottom into the hole where the axle is so that I basically have a dropout axle. I had to do this on the existing piece on the trailer as well. And then after grinding my welds down for about 20 minutes, I could finally put the two pieces together and drop a wheel in place and then work on the alignment. So basically I just measured from the edge of the rim to the edge of the frame, and once they were the same at both the front and the back of the rim, the wheel was aligned with the frame. Then I did the same process for the wheel on the other side, which was a bit narrower because I was using a front wheel again. And then gave it a final grind down and sand. And then some more primer and paint. So I'm going to be converting my normal bike into an e-bike, but first I'm going to build a battery for that. I decided to build a battery instead of buy one because first of all, you can build one much cheaper, and second, nothing really had the capacity I wanted. I knew I wasn't going to get the range a normal e-bike does, pulling a 140 pound or probably 200 pound by the time it's finished trailer behind me, so I wanted something with a pretty large capacity. Plus, this is called Drew Build Stuff, not Drew Buys Batteries. So I had never done this before, so definitely don't take my word too religiously on any of this, but I followed a 5-part series by another YouTube channel called E-Bike School, and I put that link up in the top corner right now. It's really in-depth on this battery process if you realistically want to build one. So I ordered these 18650 lithium-ion battery cells, 221 of them to be exact, from a site called 18650 Battery Store. And what you see me doing here is I'm testing the voltage on every single cell to make sure they're all within a hundredth or so of a volt of each other. If something was too far out, I'd use a charger to bring it up to about the same as that 3.63 that everything else was at. But if you found one that was really low, say like under 3 volts, it's probably garbage and has a discharge problem, which is why you really want to make sure you get these batteries from a reputable source. And of the 221 of these I ordered from the 18650 Battery Store, every single one of them was within a few hundredths of each other. The claimed capacity on these was 3050 milliamp hours, so I decided to test that, and I burnt a couple batteries out by just running them in a flashlight for a while. You can see here they're at about 2.5 volts, which means they're dead. And then I charged them up to their full capacity, which is about 4.2 volts, and both of them had a capacity that was over the 3050 milliamp hours. So these numbers are the same for pretty much all 18650s. Most of them are dead at about 2.5 volts, and most of them are fully charged at 4.2 volts, and their nominal voltage is the 3.7 volts. So I want to make a 48 volt battery pack that will support the e-bike conversion kit I got. So to do that, we're going to have to connect 13 batteries in series, which would ultimately be the 3.7 volts times 13, which is about 48 volts. On top of that, I'm going to connect 17 of these batteries in parallel, which will up our capacity from the 3050 milliamp hours to about 51,000 or 51 amp hours. So our full battery will be 13 cells in series and 17 cells in parallel, or 13 by 17, which is 221 cells in total. But that's enough theory, let's build the damn thing. So first I'm hot gluing together strips of 17 batteries all in the same alignment or in parallel, which means that their positive end and negative end are both at the same ends on every cell. And I did this until I had all 13 parallel groups glued together. Next I'm using some 8mm nickel strip, and I'm going to spot weld all of these cells together so it ultimately is one big 3.7 volt by 51 amp hour battery. So this is a cheap spot welder I got on Amazon, and basically all you have to do is put one of the probes where you want a weld to be, and then place the other probe where you want another weld, and after its delay time, which I have set to 1 second, it'll automatically make a short circuit and make a weld. And once I had all 13 parallel groups all spot welded together on both sides, I can glue them all together into their final formation. You want to make sure these go every other, being one side would have negative up, and then the next set would have positive up, and then the next set negative, positive, negative, positive, and so on. Before I start doing the series connections, I also like to write these positive and negative ends on both ends of the battery so that I don't get too confused. Now for these series connections. So basically one negative is going to be the negative end of our entire battery, so it's left on its own. And then we're going to connect positive 2 and negative 3 together, and then skip one and connect positive 4 to negative 5, positive 6 to negative 7. Then when we flip over the battery to the other side, we're going to connect positive 1 to negative 2, and positive 3 to negative 4, and so on. So to make these series connections, I'm using a whole ton of these short lengths of nickel strip and spot welding them into place the same as I did on the parallel connections. So now I have all our series connections done, and our -1 group is going to be the negative terminal of the battery, and the positive 13 group is the positive terminal of the battery. And if we check the voltage on our two terminals, we should come out right around 48 volts. Now this is an active battery, but in order for it to be usable, we're going to have to use a BMS, or a battery management system. So this is a 50 amp 48 volt BMS, which should work perfectly because our e-bike kit uses 30 amps with a 50 amp max. So first I'm soldering on some silicone wire onto the terminals of this BMS, and then we're going to attach it to the battery. So I first just hot glued down a little bit of foam, and then glued the BMS right on top. So the B- terminal on the BMS gets connected to the negative terminal of the battery, and I use some 10 gauge silicone wire. I then strip that back all the way, and I'm going to solder it at multiple points along this nickel strip run. But first I tinned a few spots along the strip with some solder, making sure to touch between the cells, not directly on top of one of the individual cells so I don't overheat the battery. And then I just started soldering down that whole run of 10 gauge wire. This is an active battery, so you want to be really careful not to touch any of the other terminals with the wire, or you'll probably cause a short circuit. Would be a good idea to cover up the rest of the battery so only the negative terminal is exposed. Now I'm taking a piece of red 10 gauge silicone wire, and we're going to solder that onto the positive terminal of the battery. This doesn't go through the BMS because the BMS only controls the negative current. So the output of this positive wire will go straight to the load discharge connector, or basically straight to the e-bike. Now with all these little wires that come out of the BMS, these go to the positive terminals of every single cell group. So starting from the first one, you'd have +1, then +2, +3, +4. So one of these gets soldered to each cell group accordingly, and that's where the labels we made earlier help quite a bit. So that first one I soldered was +1, and then +2 will be on the other side of the battery, so there I just soldered on +3, and then this one's +5, and so on. Then on the other side of the battery, we're going to solder on the +2, 4, 6, 8, 10, and 12 terminals. There's also a black wire on this BMS which goes to our -1 terminal, so I'm just going to solder that on right on top of one of the existing solders on our negative terminal. Now if we check our 2 discharge leads, we should be right at that same 47.2 volts. Now before we close up this battery, we have to add some charging cables. So I'm using some 14 gauge silicone wire, and I'm going to solder our red lead straight onto the positive terminal of the battery. And our negative charge cable is actually connected into the C negative terminal on the BMS, so we don't need to do anything with it. Our B minus terminal is the one we soldered straight to the entire negative lead of the battery. And our P minus terminal is what will go into our discharge connector, or basically straight to the e-bike along with the red cable we soldered on. Before I closed it up, I also took our 2 charging leads and connect them onto a DC charger port and plugged in the charger to make sure the battery would accept a charge and everything was working before I closed it all in. Now with all the cables coming out of the battery that we need, I just taped up any loose wires and wrapped it in some foam. And then wrapped the battery in some heat shrink. Also, apparently no one in Canada carries any big versions of heat shrink, so I had to do this in a couple pieces. So that's a finished 48 volt 51 amp hour lithium ion battery that cost me under $1,000 Canadian to build fully. But how am I going to connect this to the bike? Well, the answer is I'm not going to. Using this waterproof camera case, I'm going to house the battery and mount it onto the tailgate of the camper, and then run a wire along the frame of the camper and basically just connect it to the bike when you hook up the camper, just like you would when you connect the lights when you hook up a trailer to your truck. But first, let's connect all the cables. So here's the charging port I'm using, which I have in the description below. So I'm going to have to drill a hole and mount this on the case. And then solder the charging cables, red to red. And black to black. And for our discharge connector, or basically what goes to the e-bike, I'm using this XT90 plug. And I'm going to mount it in place in the side of the case. Then I soldered on the positive and negative leads onto the XT90 plug and capped it off. Then I fed the wires back into the case and siliconed that plug into place. One last thing for the battery, I'm just adding this cheap voltage meter that'll tell me how much battery capacity is left. So I traced on its shape and cut a hole through the front of the case. And then I fed the wires through, and I'm going to silicone that in place. Then I just soldered the 2 little wires onto the positive and negative ends of the battery. And then the voltage is working. The capacity seems to always say 100%, but I wonder if it maybe learns as you charge and discharge a few times. So this is a 48 volt 1000 watt e-bike conversion kit I got off of AliExpress, and it came with pretty much everything I needed for this kit except for the battery. So this was actually really easy to set up. It only took about an hour. So basically you just replace your back wheel with this wheel that has a motor hub. And then I just switched over all my components, including the flywheel, the disc brake, and the tire itself. One really important thing with these wheels is you want to make sure you have a washer on the inside of the dropouts. And then you're going to use one of these lock washers on the outside with the point facing to the opening of the dropout. And then it can be bolted on, and this is the same on both sides. So this is the controller that came with the kit, and it just has an easy plug and play for every piece that came with it. But the battery didn't come with the kit, so I'm going to take these red and black wires and snip them and solder them into one of our XT90 plugs so it'll accept our battery. And I forgot to put the end clip on these wires before I soldered them in, so I'm just going to cover this up with some electrical tape instead. So I added on the display, the on, off, and mode buttons, and the throttle there. But I'm not going to add these brake levers that came with it because mine have the gear shifters built right into them. And I think all these really do is cut the power when you use the brakes, so that's fine. The bike will be better for doing burnouts anyway. Then I have this plastic casing that I had to buy separately, but I think it was like 20 bucks, that I'm going to house the controller and all the excess wire in. I also modified the trailer mount to make it bolted straight into the chainstay arm. So to do that, I'm going to weld it onto a 1/4 inch piece of flat bar. So I sanded off the paint on the mount and then just welded it straight onto the flat bar. Then I smoothed everything up with the angle grinder. And gave it a bit of a bend in the vise before drilling some holes for some 1/4 inch bolts, drilling through the frame, a quick coat of rust primer and paint, and locking them in place with some 1/4 inch bolts and nylon lock nuts. Now to get power to the controller, I had to make up a couple of cables with that 10 gauge silicone wire and some XT90 plugs. One shorter one that I can zip tie onto the frame from the controller down to where the trailer hitch is. And I'm also zip tying up the motor cable that runs to the controller here too. And one longer cable that runs from the hitch all the way back to the back of the trailer where I'm going to mount the battery. To mount the battery pack on the back of the trailer, I took some aluminum angle iron and then drilled a couple holes into the battery pack case with the battery taken out, obviously, and then bolted these pieces into place. Then I took 2 more pieces of aluminum angle and I'm going to bolt these into the back of the trailer. I left about a 1/4 inch more of gap between these 2 pieces so that the battery suitcase can just slip right between them, and then we can pin the 2 pieces of angle together. And on the inside, I bolted these in with some large diameter fender washers and some nylon lock nuts. So then I just drilled some 1/4 inch holes through both pieces in all 4 corners. And then on every corner, we're just going to lock this in place with some 1/4 inch lock pins. I wanted to make it removable because it's a pretty big battery, so I might use it on some future projects. Plus I can remove it to take it inside to charge it, or if it's a really hot day, or if you're just worried about theft or whatever. Now we can finally connect the battery pack and see if we have any power, or if I just wasted $1,000 building a battery I don't know how to build. The last thing I'm going to do for this build is I'm going to give myself some usable USB and AC power. So I have this 100 watt flexible solar panel that I'm going to put on the outside of the camper. And then I have this solar power bank that I'm going to put on the shelf inside the camper, and then run the wires in through the roof so that it's constantly charging this battery bank. So the battery came with the solar connector, and all you have to do is connect the MC4 cables, and then it uses a DC plug that plugs right into the front of the power bank. So first I'm going to glue on the solar panel with some silicone caulk. And then I'm actually going to cut off these MC4 connectors, otherwise I'd have to drill a really big hole in through the roof. Then I also cut the connectors off the power bank input cord. And then I'm just going to solder these wires together, positive to positive and negative to negative. I didn't have enough room in there to film the soldering, so here's a clip that looks like I'm definitely hotboxing it. Then I just covered up the open wires with some heat shrink. So I should have pretty unlimited power with this, using just basically stuff that I charge with the USB cord. But I have tested it, and you can actually charge the e-bike battery with this power bank using just the normal AC charger. The only problem is this power bank is about 6 times smaller than the e-bike battery, so you'd have to charge it in a bunch of chunks. And in this clip you can see the solar panel is generating about 60 input watts into the power bank in pretty clear sun. Now the camper version 2 is ready to go. I have a music festival this weekend that me and my friends throw every year, so I'm going to bike this out to that and camp out for the weekend. It's about 45 kilometers away, and I've never even rode this yet, but no better way to learn than to just dive in. So far I've done 0.8 kilometers on this e-bike, and I'm starting on my journey right now at 3:36. After a few kilometers I had to pull over to adjust my back brake that was dragging, but after that everything was pretty much perfect. So I really had no idea how long the battery would last, so I was kind of doing it around 25, but after I got halfway, I just started going full throttle, about 35, even on the dirt roads. Having support on both sides of the wheels, as well as the rigid hitch on the chainstay instead of on the bike axle, has played a huge part in stabilizing the trailer compared to the first version. Plus, the weight of the two batteries at the back of the trailer has given it pretty much perfect weight distribution. After about 15 or 20 kilometers, I felt really confident with it, and I could even kind of speed wobble the bike to see how the trailer would do, and it just kept on trucking straight. So my whole trip was 44 kilometers, and I did that in about 3 hours, but you can see in the top corner the actual runtime on the bike was 1 hour and 47 minutes. The battery's still at 48 volts, so I'm going to see if I can make it home after the weekend without charging it at all. And I should note that I didn't really pedal the whole time. Yes, I was moving my legs around, but they were doing pretty much nothing. It just felt weird sitting there not pedaling. But for this weekend, it's time to enjoy the music.
I feel like I'm on my own when I think about you coming home. Baby, you're on your own, 'cause you know I'm never coming home.
By the way, this is my band's song, Go, if you want to check it out on Spotify or whatever.
So baby, go and leave me behind. Oh baby, go. Leave me on my...
And a couple days later, it's all over, and it's time to see if I can make it home on this one battery. So I made it home another 43 kilometers in just under 2 hours, with a little bit of filming time. And again, that was with very little pedaling, so I think it's safe to say this battery has an easy 100-kilometer range. This camper is now infinitely more usable than it was before. To be honest, it pretty much just sat in my backyard before because it was so hard to pedal around. But now it's actually very practical and fun to drive around, and I can't wait for the next trip. If you like this video, please consider subscribing. I do a whole bunch of different build videos, and just a like and subscribe goes a really long way in helping out channels like mine to make better and better content.